In this lesson, we'll discuss the time of arrival tool. And the time of arrival tool is used to create a track for a point or a line similar to the distance speed tool. But it also allows the user to identify a point to calculate the time of arrival of a specified feature at that point. Let's start off by loading a maps bundle. Now to do that, we want to go up to the File menu, select Procedures, and then select Open. Left click on the caret next to Site and click on the last one and then press OK. Next, let's double click on this bundle to load it in. And once the bundle is loaded, let's go ahead and close out this window by clicking Close. Next, let's load a radar reflectivity product. So go up to the KCRI menu and go down to KCRI Z and then over and up to 0.5Z best res, and let's go ahead and load that one in. Now before we proceed, let's go ahead and dim down the radar display so that when we load the time of arrival tool, it'll be easier to read. So press the Control and I buttons on your keyboard at the same time, and this window should pop up. Let's turn the brightness down from 100% and drag it to 60%. Okay, once you've done that, let's close out this window. And one more thing we need to do is let's change the frame count from 64 to 12. Select 12. Okay, now we are ready to load the time of arrival tool. So go up to the Tools menu and then go down to time of arrival or lead time and load it in. We are given a few options: point, circular front, or a polyline. Let's go ahead and start off with a point, so click OK. Now it looks like the text is a little too large for our time of arrival tool, so let's go ahead and right click and hold on time of arrival in the product legend, and let's change the magnification. So let's go up to magnification, then over and down to 1.5, and that should be just about right. Okay, let's go ahead and zoom in on our storm, and we are prompted with a drag me to point of arrival and a drag me to feature icon. Let's start off by using the drag me to feature icon. Now we normally want to drag this drag me to feature icon to a hook or an inflow notch, but let's go ahead and loop through the data and you'll see why that may not be the best course of action for this storm. As you see, the hook is very noticeable in the earlier frames, but as this record-breaking 2.6 mile wide tornado gets going, it occludes and gets slingshot to the north. So using the inflow notch of the hook would not give you a representative storm motion vector. So let's go ahead and actually use the hail core just northwest of the tornado. So go to the last frame of your radar data and let's go ahead and drag this drag me to feature icon to the hail core just northwest of the tornado. Should be right about there. Okay, now let's go back a few frames and let's go ahead and drag this point to the same feature, the hail core, in an earlier frame. And let's go all the way back to the first frame and make sure, looks like right there. And next let's loop through the data to make sure our storm motion vector is accurate, and that looks like a good storm motion vector. Next we want to place the point of arrival to a location of choice. So let's go ahead and zoom in on our map and let's go ahead and put the point of arrival in the town of Choctaw. Okay, So this feature should arrive in Choctaw in approximately 1 hour and 31 minutes on its current motion, and Choctaw is 34 miles away from the feature. Next, let's unload the time of arrival tool. So to do that, we right click and hold on the time of arrival text in the product legend and select unload. Next, let's load the time of arrival tool back in and practice using a polyline instead of a point. So go to the tools menu and let's go down to time of arrival and load it in again. Now instead of point, let's click on polyline and select OK. Now you want to use the polyline feature on something like a bow echo or some kind of squall line, some linear feature, but it looks like we don't really have that, so let's just create one. So let's target the convection to the southwest of the radar site, and let's get to the last frame of the data, and let's go ahead and shape our polyline feature in the shape of a bow echo for that convection to the southwest. We want to left click and hold on the polyline and drag it to our feature, and next let's shape it. Take this vertex and bring it down to kind of trace the leading edge of the heavier rain. Take this guy and bring it down. Let's go ahead and practice adding an additional vertex. To do that, we middle click somewhere on this line and you'll see an additional vertex pop up. You can zoom in to your liking. And so let's kind of shape it to mimic the leading edge of the bow echo. So there. Let's step back a few frames. And let's shape it. Step back to the first frame. And let's loop through the data. And that looks like a pretty good storm motion vector. So let's go ahead and zoom out. And let's grab our point of arrival, which is right here, and let's find a good location to put it. Let's put it somewhere between Chickasha and Paul's Valley, right about here. And if we zoom in, there's a town of Lindsay, so let's go ahead and actually put it right next to Lindsay. So there we go. Looks like our text is still a little bit too big, so let's go ahead and right click and hold on time of arrival and change the magnification from 2 to 1.5. Okay. So it looks like on its current track, the leading edge of the heavier precip should arrive in Lindsay in approximately 1 hour and 3 minutes, and Lindsay is 29 miles away from the feature. So you can see how the time of arrival tool can be useful in decision support services when you are tracking a storm to a particular location that could be holding an event such as a concert or a state fair.